I'm Brian Matthews, as Marion said. I am the DAFNI Project Lead at the Scientific and Computing Department at the Rutherford Appleton Laboratory, which is a laboratory of the Science and Technology Facilities Council. And if you don't know who we are, I'll explain in a little while. Okay, and I'm going to give us an introduction to DAFNI. Now, William has already given a brief introduction of where DAFNI fits in the UCRIC landscape. And I'm going to give a little bit more detail about what we're trying to do, and what we've done, and a little bit about some of the examples of how we're being used. Okay, so why are we doing what we're doing? Well, firstly, we're looking at some of the technical e-infrastructure challenges of infrastructure research. So like all aspects of research these days, research into infrastructure systems is increasingly computer dominated, with the use of a lot of data and a lot of models. And well, what we find is that university departments or individual laboratories may they're doing good work in all those areas, but they may come across particular limitations or challenges which they come across when doing computer modeling and using large amounts of data. Firstly, just the sheer volume. We're trying to use more and more data. We are getting higher and higher resolution. We want more and more computer resources, and that just stretches the availability of resources that might be available to an individual computer laboratory. And we also want to be able to share data and share work much more between us. And we want to be able to share data between models. We want to be able to share data between research groups in ways that respect security and ownership of data. But also, we also want to use common standards for interchange and interoperation between different data and common metadata standards to enable all that. And equally, we want to be able to integrate between models. We want to be able to capture the independencies between things. We want to be able to take an individual piece of equipment on an individual site, combining those together onto a site, combining all those together into an organization and combining up with that into the scale of a region or a city, and then combining that up into the whole country. So it's this huge problem if we want to link up different scales of the system. Equally, if we are interested in infrastructure in water, energy, land use, digital infrastructure and transport and built environment, and how to represent the interactions between those things, we have another very serious integration system into building one infrastructure model or infrastructure twin. And we also want to be able to integrate with environment, the natural environment, and the human and economic and social environment. So we have this very significant integration problem, and this becomes even more so if we look at digital twins, which is the emerging area of this. We want to be able to integrate that with real-time sensors as well. A very significant integration problem. So this is where DAFNI comes in. DAFNI as a community hub, a place where we can share those data models, we can bring them together, so people from different places could use them and integrate them together. A place where we can support collaborations, and also a place as a legacy. We find that that models and data might become difficult to access or difficult to use as time goes on and projects finished. If they're kept in a place for the long term, we can then come back and reuse them. So this is what we're trying to do in DAFNI. So DAFNI is an infrastructure in its own right. We provide a hybrid high-performance computing platform at the Appleton Laboratory with some reasonably significant compute resources. But on top of that, we are building, we built a software stack on top of that, which provides us with a secure repository for heterogeneous national infrastructure data and models. And that gives us a platform where we can collaborate together to research and develop these multi-systems models of infrastructure assets and systems, and also a place where we can store them for a long time and have people have expertise available to keep them alive beyond the end of the life of individual projects. So that's what we intend to do. What are we actually offering? Well, DAFNI as already been mentioned, is one of the UCRIC programs. We are formed by a collaboration of 12 universities, led by the University of Oxford, plus ourselves, who are STFC, based at the Rutherford Laboratory, not too far from Southampton, between Southampton and Oxford. And it's an £8 million programme, under the programme from 2017, and completes this year. We've just recently received an extension on into September this year. We at STFC, we're the host. We are providers of large-scale infrastructure, research infrastructure to support the research community, including large-scale computing resources. So it's kind of our job to provide significant computing resources to the and support and run them to the research community. So that's why we were asked to help host this. And what do we do? Well, this is kind of a few screenshots of giving some of the functionality. We have a login. Well, you might expect that, but that's kind of a proxy that we have a sort of security infrastructure and access control infrastructure, which controls access to particular resources to the data on the system. And on top of that, we can allow people to upload different data sources, provide and then find those data sources, and we find them through a data cataloging system. We can allow people to upload computer models, and I'll explain a little bit more about how that works in a bit. And we can combine those models together using the system, even though they come from different places, into a common workflow. We combine it with the data that's in the data catalog, and execute those workflows, and then eventually give us some good visualizations of what they're doing. All these components are in place. The visualization as yet isn't been released, so I won't really talk about that much more. I think some of the support that in the demo, but we are working on another visualization interface was not actually released. So what I'll talk about a little bit more is how we do data and workflow, and that'll tie into the demonstrations we're going to show later. So firstly, we have a data hub, if you like, a repository with a catalog of data, which gives us this data sharing, data integration, data curation capacity. We call it the NID, the National Infrastructure Database, as a secure place to hold data, which is released as the user sees fit. So the user can release it to, or not release it at all, use it themselves in their own models, or release it to a group of researchers or groups of researchers, or release it openly to everybody. And this catalog is got a rich but very broad metadata framework for representing that, giving information about that thing using a standard called DCAT. And how we're kind of developing this gives us a platform integration combining data, but we're still working on it and how this might actually be made richer. We want to make it provide much more rich information management framework for different sectors, water, energy, transport, etc. And we're looking at developing this into an ontological framework. And this is sort of, we are looking at some preliminary ideas around this, and will probably come out in the next phase of the project. We'll provide much richer support for this. So that's the information rich, the NID. We'll see a demonstration of that later from Bethan. And then there's the other side, which is supporting models. We try to provide a system where models can be sort of first order uploaded from anywhere. We use a system called Docker to sort of containerize, package up models from different places, which gives a lot of independence from the programming language they're written in, the libraries and other dependencies, that would makes them a much more a flexible way, a way of bringing things into this, bringing models onto the system, so they can be executed on our system and shared, all within the same security framework, of course. And that runs on our HTC cluster. It gives us that scaling up. We use a system called Kubernetes to orchestrate the flow of containers, and then we can build workflows. This screenshot here gives a particular workflow that we can build using the workflow building tool, chain couples together, models together, chain them together, use data that's in the data catalog, and then we can do this system to systems approach. So finally, a few quick examples of how we're doing it. I slightly hesitate to say this, to say a lot about this one, but this is a model an example we did a while ago with the University of Southampton, looking at a station demand model, seeing where you place a new railway station on a line and how that affects the sort of the catchment of that thing where passengers are going to come from to use that station. And so you can choose the best place to place the station. And this is another model on the right, which is the Simming model of University of Leeds, looking at economic development as infrastructure changes, in this game in the Oxford-Cambridge corridor, actually, as we mentioned before. These give sort of early pilots of ours, and they show how some of the scaling up capability of DAFNI can be supported. One of the very big models that we've been looking at is DAFNI, but I think ITRC has already been mentioned. So we've been working very closely with them on their NISMOD, Systems of Systems model, which brings energy, transport, digital, water and waste systems together. And it's been quite an effort, but we have now got this on the platform, and we're using the workflow systems as I've described to support that. So that's now running, and I think I'll talk a little bit more later from Adrian. And we're sort of building on that NISMOD work in a new project that we've just started in the last few months called OpenClim, which is with the University of Anglia. It's still in relatively early phases, and what we're doing is building some workflows which we'll bring onto the system. So what this project is doing is looking at the risks associated with climate change. So this thing here brings in together climate data, climate prediction data on this side, brings in urban development models of how towns and cities are going to develop over time, and then combine them together into various flood models down the bottom here to see how, as climate change happens and urban systems develop, how that affects the water and flooding distribution in that city for flooding events. And then that project is looking particularly at adaptation, how we then change what we do in urban development, or change what we do in outside the city in upland areas, for example, in the catchment, to try and mitigate the various flooding scenarios. So this is, as I said, very early days project. So I think this is something very exciting will happen in the next couple of years. And a final example is an example of a digital twin, or at least the start of a digital twin. Digital twins have sort of emerged as DAFNI has progressed. So we've been sort of adapting what we're doing to accommodate them. And this is working with the Urban Observatory, and again, already mentioned that in the UCRIT context, the Urban Observatories. In this case, the Sheffield Urban Observatory, which has a lot of sensors around the city on traffic flow. And what Christian Jeans at Sheffield has done is built an AI-based model to predict the evolution of traffic flows over the next 30 minutes. He's brought that onto DAFNI, and we take real-time or near real-time data from those those sensors and run the model to predict flow. And in theory, we don't actually do it at the moment, but in theory, we could send back the results back to Sheffield to do real-time traffic flow optimization. So that's some of the examples. So just a quick summary of what we offer. We offer an environment for research collaboration with a HTC platform, which gives some scale up, but more specifically data sharing in a common information infrastructure, a way of sharing, scaling and coupling models together, and a long-term legacy. There's still a lot of work to be done. Our digital twins are still very much in pilots at the moment, for example. We're still looking at some of the more increasing the richness of the data management frameworks and data ontology support, but we've got plans to do those sorts of things over the next year or so. And just a final word, we are open for business. We've been in the development phase for the moment, and we sort of have a relatively small number of pilot users. That is actually increasing quite a lot over the last 6 months. But so if you have to have pilots suitable for the program, talk to Simon Blaney, who is the Southampton representative on the DAFNI governing board. Discuss with us, talk with Marion, talk with myself. We can provide logins to try it out, and if you feel there's a role for DAFNI in future projects, please come and talk to us. We're eligible. We're hoping that there will be access to the system as is, but also for more sort of richer, more advanced use. We'd be we're happily be part of research projects. So please talk to us if you want to, more interested in DAFNI. So that, I think, is all I had to say. I think it's time to get on to the demonstrations, and then you'll see DAFNI in action.